Hello and welcome to Delmi Training Institute's DTIL 101 Introduction to Network Cabling. And today we are on lab number 6, creating a straight-through shielded RJ-45 patch cable. Well, let's look at the lab objective and the material that we require. So the lab objective would be to create a category 5E or a category 6 shielded twisted pair network patch cable or patch cord. And once that is done, we're going to test for continuity using one of these testers to identify correct continuity as well as the pinout to include the shielding on the cable. For this lab, the material that we're going to require includes a category 5E or a category 6 shielded twisted pair cable. Oh, this could be a foil twisted pair cable. We also would need an RJ-45 shielded twisted pair jacks like this. And I want to send a big shout out to TSOC. So TSOC, they were very kind enough to send us shielded RJ-45 crimps, jacks that they do have, the shielded twisted pair jacks. We are going to be using that in this lab today. Well, we also need a twisted pair cable stripper that is capable of stripping a shielded twisted pair. And this is ideal to do that work because we have this that has the adjustable dial on here, and it also has the stripping option here. So we're going to need that one. If not, we can also use an electrician scissors or a side cutter if you're comfortable working with these. Next, we need an RJ-45 crimp tool. And as most of you have seen from previous videos, these are the crimp tools that we have. I'll talk about them in a second. And finally, a cable tester that's capable of testing the shielding. So in previous videos we've been using this type of basic tester, but today I'm going to introduce another cable tester from Fluke that would properly show the pinout configuration in a graphical experience so we can also see it, and that is the dummy end, so we're going to be using that. Well, so now that I've spoken about the material that we need, I'm going to go ahead and talk about the lab procedure. So the lab procedure would be, first of all, to determine the length of the patch cable that you need to create. In this scenario, in this lab, I'm going to create about 1.5 feet. So that's what I have, that piece of cable, and I'm going to be terminating using a shielded RJ-45, but these are non-pass-throughs. So when I say non-pass-throughs, which means that when I terminate them, the cables are not going to come through. This requires careful arrangement of all the cables to conform with the various pinouts. So that is what we're going to do for step number 1. And step number 2, as usual, we are going to strip about 1 to 2 inches of the jacket off one end, and keeping in mind the shielding. So that's what we're going to do. You can either use this tool, and I've explained the use of these tools in previous videos, but I'm just going to quickly just talk about it. So this tool is from Fluke. It's got the cutting side and it's got a stripping side here, and so once you adjust the blade on, you adjust that rotary dial, it actually adjusts the depth of the blade. So if you have a cable and you want to have like a very nice cut, you can use the cutting side. Having said that though, I've seen other people try and use this side to strip cables as well. It all depends on your settings. You can still do it. My recommendations is to use here to strip, but if you find you're comfortable as well. So if you want to have a smooth cut, you adjust your blade all the way down and just insert your cable in like that. Give it a nice little squeeze this way, and it's going to cut through it. If it doesn't go all the way through, you're not going to get a clean cut. You could see it did cut briefly, which means that the blade is not adjusted all the way fully. So I can go and I can adjust that all the way down. So now I've been able to adjust it all the way down here. I'm going to insert that piece of cable again through like that, and I'm just going to give it a little squeeze, and this time it cuts through, giving me a nice clean cut. So well, by adjusting that, notice how deep the blade has been extended, and this plastic here is supposed to let you not cut deep into the sheeting to get into the shielding. So by just visually looking at it, the blade has extended so much, so I'm just going to retract that a little bit to make room for that. And again, by taking a close look at it, I've been able to lift the blade that much higher in. So the second step was to strip 1 to 2 inches of the jacket of the cable from one end, bearing in mind to keep the shielding in. So I'm going to give it a first try. There, keep it on and just spin it around a little bit. And once you take that off, you could see it did score onto the jacket, and I can break that off like that. I am guaranteed that I did not cut through because I had to do a little bit of bend on it. So this is what I have. This comes with a ripcord, and you can always cut that off because you don't need it in this application. Now I'm going to inspect just to make sure that nothing on the cable or the foil was cut. Next is I'm going to unfold the shielding and roll it back onto the unstripped portion of the cable jacket. And by so doing, I'm going to hold all the 4 pairs of twisted cable tightly where the jacket was cut away. And the strategy here is to open the foil up like this. And once I've opened this up, this is what I've always done. I use my index finger. I just lift this up a little bit and I lay my index finger in here so I don't have to collapse it. So I hold that, stretch it up a little bit, and the goal is to keep sliding that in, and I'm going to rip that. I'm going to bend it backwards all the way here. Once I do that, I'm going to stretch it a little bit so that I can have it uniformly wrapped around the cable like that. And the moment I do that, I'm going to expose the drain wire. And the drain wire is responsible for carrying away all the transient voltage or any noise and grounding it. So by pulling this, if you notice that the foil got ripped off, which means that during the stripping process you nicked a little bit of the foil. You wouldn't be able to stretch this all the way down if you nicked a piece of it. So that is an indication of you not nicking onto it. So this is what I have. That's the third step. So you should be able to have something like this. In this particular cable that we're working on, it has a plastic that wraps around the individual pairs. So what I'm going to do is cut that off as we do not need it. I just nick a little bit around it and I rip it. So let's look at step number 4. Step number 4 would involve the reorganization of the cable pairs in order of either the 568A or the 568B wiring, and also take care to maintain as much twist as possible to provide any noise cancellation that might be. So you want to make sure you don't unravel it all the way in, because that's going to create some crosstalk. For the purposes of this lab, we are going to be terminating using the T568A, and the color coding of the 568A is this color code here, and that for the 568B is this color code here. So depending on your geographical location, if you determine to do the A or B, you can follow either this code for the A or this color code for B. Now, so by moving on, I'm going to reorganize this. So the 568A starts with the white green, and that's just what I'm going to do. But before I start to reorganize this, there's the drain wire. I'm going to take that and I'm going to wrap it around the foil. I'm not going to cut that. It plays a very vital role in the termination of this. So now the drain wire has been wrapped around the foil, and I'm going to start unraveling each and every one like we've done in other labs number 3, labs number 4, etc., etc. So once the cables have been unraveled, and like I've always mentioned in previous labs, the key to a successful termination is to make sure that there are no twists in each pair. So take time to straighten it all out, make them all as straight as possible. If you cannot use your fingers to do it, you can always use your lineman scissors to take all the kinks out, or you can also use that. Just line it up properly like that, put your thumb on, and you do it. You can do it one at a time. So this takes us on to step number 5. So step number 5 involves the process where we have to hold the tip of this and start to arrange the cable. So hold the jacket and the cable in one hand and begin to reorder the pairs to reflect the T568A wiring scheme. So let's start with the A. The A wiring scheme starts with a white green. So that is what I have, followed by a solid green, and then a white orange, followed by a solid blue, and then a white blue, and the solid orange, white brown, and a solid brown. Just like this. Let's look at step number 7. Step number 7, I'd have to flatten this portion of the cable to make sure that it fits into the RJ-45. It becomes a little bit tight because the form factor of these jacks would remain the same whether it's a shielded or a non-shielded. However, with the shielding, they have to put a piece of metal foil around it, and this takes away from the amount of space that you have to insert the cable. So for it to go in, it's a circular cable, but it's going into a rectangular opening. So I always like to flatten this portion a lot. That's a key step, so that I'm able to achieve like an oval shape, allowing this to easily fit into the RJ-45. So once I have that, I'm going to put this next to it and I'm going to measure it, and then once that is done, step number 7 says flatten and line the wires up and trim the sides with a side cutter or a scissor. So this is what I did trim. I'm going to put it next to it, and I'll just trim a little bit more. Now let's move on to step number 8. Step number 8 just involves me sliding the RJ-45 gently onto the cable. And like I've always said, when you hold the RJ-45 with all the golden or the gold plated pins facing up, your pin 1 is always going to be to your left, and my pin 1 here is the white green. So the white green is the pin 1, and that's just what I'm going to do. So I'm going to align that and start to slide this in, ensuring that the shielding goes all the way in, and I'm going to continue to wiggle that until it goes all the way in. And I should take a visual inspection onto this. I can see very well that the cable, including the foil, has made its way all the way here, and that just tells me that I've had enough of the jacket. Next thing is I'm going to look on here. This is the only window that I have to verify the colors. That is the only window. I cannot see them from here. I can see a tip from here, and these ones from TSOC allows us to see the colors from here. And also I'm able to verify that I can see the copper on the side of it. Once I can see all the copper within the glass, that means that my cable has made it all the way to the end. If you do not see that, chances are your cable is not going to pass. So these are a few key indicators. I'm able to verify the color, the wiring color scheme that I'm using, and in this situation is going to be the 568A. So the white, green, solid green, white, orange, solid blue, white, blue, solid orange, white, brown, solid brown, as aligned in here. Jacket made it its way all the way in, so I just tried to push it all the way as much as I could. Verified the colors again from the top, making sure that they've made it all the way to the end, and also I verified them from the top. Once you've done all this, your cable is now ready to be crimped. I can either use this as you've seen in previous videos, or I can also use this. Now these two are all pass-through crimps because, like I did mention, they have the blade in it. Or if you do not have any of these, you can also opt for ones like these. This has no blade on it, and for that reason it's able to just crimp but not cut. And I can see all the ridges that are here. They are what aligns with the golden pins that are going to be here, and these ridges are just going to force these to go in to make good contact with the RJ-45 and the copper solid strands. Right, so I'm just going to use this one because I prefer using that one. I just hear that ratcheting noise and it gives me satisfaction that I've been able to crimp it properly. So I'll take that, insert that in like that, making sure everything is there. Then I'm going to give it one crimp, and that is it. So this is step number 10. Crimp the plug by applying pressure onto the tool enough to force the contacts through the insulation of the wire, completing the conducting path. There is one more step that I have to do. Notice how I have this excess foil on the cable. I don't need this, so it's time for me to trim this off. So this is where my lineman scissors or the side cutters come in handy. I'm just going to cut just a little bit of the foil from here, and I'm just going to strip it because it rips easily like that. And once I've done that, I've made good connection between the jack and the foil, as you can see. So all the foil is in, crimped properly on each side like that. Well, so having done this, I am going to repeat steps number 1 to 10 and do the exact same thing on this side. So I'm just going to go through as fast as I can, and we're going to jump onto step number 11, which is to test using the cable testers that we do have. Well, you just notice that going through this, because there was a small nick on it whilst I tried to pull it down, I broke the foil. So I have to go through that again, so meaning that I have to adjust my blade a little bit. Have to start the process all over again, ensuring that I do not nick on the cable. So this is just what I just did. Let's take a look again. Yep, there's inspected it, there's nothing. Good. So cut off the drain wire and go through that step again. Pull that back a little bit and fold it to wrap around, exposing the cable with the drain wire. Wrap the drain wire around it. Now, because I'm doing the 568A, the T568A, I have to keep the wiring scheme the same as we did before. If it was a crossover cable, I was going to do one end the 568A and the 568B. Well, so now I've been able to get this. I have verified my cables conform to the T568A, and cable jacket comes all the way in with the foil. I can see all the copper exposed there. Everything is good. So I can go ahead, grab and crimp. There are times that you might find a little bit of the drain wire exposed. Yes, you can nick it off. You don't necessarily need it because the bulk of the wrapping around the foil is already gone into the jack. And once I crimped it, this is firmly seated in. So this is what I've been able to achieve, and that takes us on to step number 11. Once completed, test for continuity or wire map. I'm going to use the very basic tester that we have always been using, and this is the one that I do have. And let's see, so plug one end into the main and the other end into the dummy. So this is the dummy portion, this is the main, but this has a ground indicator on here, and that is going to turn on to confirm that the ground has been terminated properly. So I turn that on, it goes through, and that light comes on. Once the light comes on, I can confirm that the termination has been successful on here. Also, on the dummy, it shows that the ground is terminated, so I should see both of them light up just as we're seeing. Now we've been able to verify using this very basic tester that it's good. So the next I'm going to do is I'm going to use this cable IQ from Fluke to do the other portion of the test. So what I'm going to do is I'm going to end up plugging one end into the main and plug the other end into the dummy of the tester. Next, I'm going to turn it on, and I have to do a few settings on this. Most of the times you have to go into the setup and do it, but one thing I've also noticed with this tester is even if you don't go into setup, and on each of the pairs that you do want to test, if you do not check the shielding, it's going to still test for the shielding, right? But if you check the shielding and you testing for an unshielded twisted pair, it's not going to identify that, and it's going to give you a fail. So all we have to do is you can go in here, you hit the enter button, select that, and you can go in and click on pairs, and the SH is for shielding. So that is the shielding here, and once you hit the enter button, it's going to put a check mark on that. So 1000 base T is going to test for that, and then you can do that for each and every one. The 100 base T, you hit the enter, you hit the pairs, and it's going to also check mark that. You can either go through those, or I'd notice that it does that automatically for us. So this tester is a little bit sophisticated than just the basic one. Now I'm going to hit the test and see what results we get. So test. Once I heard that beep and I see a check mark on all these, it certifies that the cable would work for 1000 base T, which is 1 gigabit per second. It would do 100 megabits per second, 10 megabits per second, and it's also qualified for voice over IP. Now by hitting this button, I also see the cable length. So this is about 0.4 feet, and this is the wire map that is showing here. I can expand this briefly so we can take a look. So by hitting the magnifying glass, now it gives me this. This gives me a graphical visuals of what is going on. Obviously the top here is the dummy end, and here is the main end. So 1 to 1, 2 to 2, 3 to 3, 4. The pinout is correct, including the shielding as indicated here. So this tester actually goes a step further to include the shielding for this cable by showing it graphically. Also, you can do many more with this tester. In future videos, there's going to be a separate lab on how to use this tester. But this just gives me confirmation that my shielding is good just in the same way as this one also did. Well folks, that brings us to the end of lab number 6, creating a straight through shielded RJ-45 patch cables. Well, I hope you found this video informative. If you did, please like, subscribe and share our videos. We are also launching our online courses soon. Stay updated by visiting our website for details and following us on social media. See you in the next one.